I will now change the perspective as I'm waiting for the presentation from single buildings and components in the building, which is the conventional perspective of architects and engineers, moving it to a perspective involving the urban climate. So why is this issue important? Urban microclimate represents, next to the issues of climate change, and growing challenge for all planners. And the question is, why should we worry about it specifically? One reason is that the percentage of people living in the cities is growing. It's projected that by 2050, about 2/3 of the world's population will be living in the cities. Europe is already reaching that level. So the urban microclimate would have major implications for everybody in the building industry. You are familiar, I guess, with the notion of the change of the microclimate of the city. People talk about the urban heat island based on various contributing factors like the morphology of the city, the materials used in the buildings, the thermal mass of the building, the surface properties, the albedo, smaller amount of vegetation, smaller amount of bodies of water. The climate in the city changes. And the idea is that because of that, in the city, urban heat islands emerge. And as you look at the temperature, especially during the night, compare the temperature within the city realm with the areas surrounding the city, you notice in almost all cities around the world a major temperature increase, a higher temperature in the city as compared to the rural surroundings of the city. So that's something that of interest to us. A few years ago, me and a number of other colleagues in the Central Europe did a European project, and in 8 cities, Warsaw, Prague, Stuttgart, Vienna, Budapest, Padua, Modena, and Ljubljana, we looked at this phenomenon of urban heat island and see how spread is it actually, and we collected a lot of data. And in order to illustrate this data for you in a way that is easy to grasp, we just plot for a typical summer day the temperature between the rural and the urban, the difference between these two temperatures. And here you see in this graph, you see at the line where it says 0, you have basically no difference. This is a typical day, 24 hours. And as you see in almost these cities, during especially the night hours, the temperatures in the city are much higher than the rural temperature. If there would be 0, would be no temperature difference. During the day itself, there may be a bit of a reverse effect that people refer to as urban cool island. But that has major implications because of, for example, in Central Europe, people have been traditionally able, at least for residential buildings, not to rely on air conditioning during the summer period. We see that, for example, in Vienna, in my city, people increasingly, even in residential buildings, are moving towards installing air conditioning in buildings. So that has obviously major implications in terms of not only comfort, but also in terms of the energy use. But we are moving beyond the notion of urban heat island because it's a restricted indicator. Instead, we're talking about the diversity, the variance of the climate in the urban, and do we sufficiently address that in planning and designing of buildings and their systems? So this diversity is sometimes ignored, but it can be significant. Just to demonstrate that using just one example, this was a work of one of our graduate students who looked in this case just at the difference between the climate of 2 streets. These are 2 streets in Vienna parallel, no more than 200 meters away from each other, exactly the same in terms of the quality of the buildings, in terms of the aspect ratio. The only difference, one street has trees and the other one doesn't. So she looked over some measurement in this area, and I show you some examples. Here you see that the street without trees has higher temperatures. We get up to almost 1 Kelvin difference. We have higher solar radiation, that's of course because of the trees. Lower humidity, measurable, beyond, so to speak, the sensitivity of the measurement equipment, and higher wind speed. And as I said, we are talking about 2 streets in a distance of no more than 200 meters. So that diversity is quite interesting. And if we look at, for our design purposes, only on a weather station at the airport, we get a very one-sided and limited view of what actually is happening in the urban complex morphology. So why should we care? I think you know that, so I just very quickly make some arguments. Obviously, it has health implications. 2003, when the heat wave hit Europe, alone in France, 3,000 people died because of the heat stroke. So it's a major heat issue. At a somewhat less critical level, it is also a comfort issue. It is also, of course, a major issue. I mentioned to you already the requirement for installation of cooling aggregates, which themselves contribute, so quasi in a circulus vitiusus, to rejecting the heat again into the urban realm. And they're expensive, and they include, obviously, environmental implications. The biodiversity in the city is affected by that negatively, and we also have social implications. For example, if you cannot use the open space in the very hot days because they are simply not unbearable from the point of view of thermal comfort. Now, people ask, obviously, okay, what can we do? There are, in the, so to speak, codex of urban design in hot and arid climates, there are already some, so to speak, knowledge and some wisdom encoded that we can refer to, and we are going back and refer to that. For example, green areas and bodies of water are helpful. You all intuitively know that. Green roofs and green facades, especially the green roofs, can have some impact, and they are being experimented with. White roofs and white facades, again, coming from the conventional vernacular architecture all the way now to the modern implementation, can have some positive effect. Pervious surfaces that allow for a, so to speak, slower rhythm of dealing with the rainwater and making use of evapotranspiration is an important issue. For me, very important also the built area reduction. So instead of sprawl growth, using, so to speak, the land for building more efficiently, maybe more compact building, and preserving, so to speak, the virgin and untouched land for future generation. And traffic reduction. The traffic is some neglected aspect here. Here you see the area requirements in the city for a pedestrian, for a biker, for a bus which is 40% occupied, and for a car in different speeds. And these are drawn to scale. So you can imagine that we need a lot of, so to speak, sealed surfaces for the cars, for the traffic, for the parking, and so on in the cities. And this neglected factor is one of the most maybe critical contributors to the urban heat island effect. And obviously buildings. Buildings, energy use also plays a role. So if we have buildings that are lower energy, we contribute to reduction the Anthropogene heat emission into the urban realm. So that would be something advantageous. From the point of view of the designers, and we can try to use modeling, the modeling, especially CFD-based modeling, is making progress. So we can actually not only look at one building, but look at an ensemble of buildings or a whole neighborhood, a whole district, and try to model the thermal and hydrothermal processes. Here, just one example where we looked at an area in the city of Vienna, in, so to speak, a contract of the city of Vienna, and we looked at a number of options such as vegetations or material-related options or combination of those, and then we looked at modeling possibilities to look at what would be presumably the effect of those in terms of the reduction of the average temperature in that district. The modeling, for example, in case points to almost 2 Kelvin possibilities of mediation and mitigation through the combination of those type of measures. But the problem with these models are that they are still somewhat slow. They require a huge amount of skill and experience by the users, and they also need to be calibrated, because with models you basically can show anything if you want to, given the complexity of the input structure of these models. So it's very essential that they are calibrated via measurements. Dr. Vukovic, who did her dissertation in the area, worked on maybe a shortcut approach which doesn't involve full-fledged CFD simulation, but a, so to speak, simplified approach, and we find an interesting potential to use certain indicators of a specific area of the urban domain, things such as sky view factor, for example, the portion of the sky which is visible from a point in the sky and is an indicator of the solar radiation that is incident in this point. That is an example of such an indicator. Or we can talk about the aspect ratio of the urban canyon. That means what is the relationship between the width of the street and the height of the street. These are geometrically fairly easy to extract from GIS data from the cities. Or we look at the compactness of the building. We can talk about compactness at the level of single buildings, but we can also think about a whole urban district. We can use those type of factors, also the albedo of the surfaces, the reflectance properties, and try to see if we can characterize multiple locations in the urban realm based on those factors. Here you see those for different areas are plotted, and we found out actually that there is an interesting relationship, and you can utilize that relationship in terms of deriving simplified indicators of what's going on. Here in this case, for example, the x-axis is a measure of heating, and the y-axis, y-axis is the overheating, and the x-axis shows the sky view factor. So we see that in different areas of the urban, you can establish a relationship between these two factors, which would be for engineers quite interesting. Here another example, the relationship between the average albedo of the surfaces in an urban area and again the overheating probability. Another example would be the fraction of the surface which is impervious and again the overheating probability. Those are indicators that engineers can easily formulate, can easily extract from the information of the cities, and through these correlations they may be able to make inferences about what measures in the long run have a chance to improve the quality of indoor environment. So through this extraction of the data using this, what we call the equation of a city, we have developed equation, for example, for the city of Vienna. It is possible to translate geometric factors and material factors into probabilities of overheating or emergence of the urban heat island phenomena. I hope that was compact and it gave you something about this, what I think is a very interesting area of research and development. And I thank you for staying awake.